Good evening, sir.
Good evening. Yeah, just give me 1 minute. Just starting one.
Good evening, sir.
Yeah, good evening. Good evening. Just give me 1 minute.
Good evening, sir.
Good evening, sir.
Yeah, good evening. Good evening, everyone. Just give me. Yeah, thank you for waiting. We can continue now. Okay. So, in the last class, we had started with chapter metals and non-metals, and in metals and non-metals, we had done the reaction of metals with. We had done types of oxides. Okay, Avino, thank you. Got your message. So see, today we will talk of a reaction of metals with water. How do different metals react with water? In the last class, we had seen the formation of metal oxides. So see, depending upon the reactivity of the metals, depending upon which metal is more reactive, which one is less reactive, depending on that, we have different types of reactions happening with water. Like some of the metals, they may react vigorously with water. Some of the metals, they can react even with cold water. Some of the metals can react even with hot water. Some of the metals, they cannot react with hot water or cold water, but they react with steam. So it just depends on their reactivity. Just the increase of temperature of water, it increases the energy for reaction. It increases the energy required for the reaction. Okay. Or you can think of that a rise in temperature of water, it provides the sufficient temperature for the reaction to take place. Like some of the reactions, they are endothermic, some of the reactions are exothermic. So some of the reactions, they may require external heat energy. So that external energy will be provided by the temperature of water. Okay. So that is why you will find that some of the metals they are able to react with water. Some of the metals they are able to react with cold water. Some are able to react with hot water. Some are able to react with steam. So first we write the reactivity series. I hope we remember it. So it's potassium, sodium, calcium, magnesium, aluminium, zinc. Yeah, what is the next one? There, zinc we have. There, can you recall what do we have after zinc?
I don't remember, sir.
Yeah, you haven't remembered? Moksha?
Yes, sir.
Moksha? Are you able to recall?
Yes, sir.
Okay. So what is there after zinc?
Zinc after iron, sir.
Okay, zinc, iron,
Iron,
and
lead,
lead. Very good.
hydrogen,
Hydrogen,
copper,
copper,
uh,
silver.
mercury.
Yeah, copper, mercury, silver, and gold.
Yes, sir.
So, okay, so these form the reactivity. Now, the ones which are at the top of the reactivity series, that potassium and sodium, they react even with cold water. So they react with cold water also. They're able to react with cold water. Calcium, magnesium, they react with hot water or warm water. React with warm water. Whereas aluminium and zinc, they react with steam, or you can say aluminium reacts with steam. Iron and lead, they do not react even with steam. So this is how you can remember the one which are more reactive, they are able to react even with cold water. The one which are less reactive, they will be able to react with warm water. Okay. Aluminium will be able to react with steam. But now see what the products will be formed. NCRT. So see what the product will be formed. In all of them, the product, the first or the primary product form is, you have something like this. You have metal reacting with water. So metal with water, it gives us metal oxide and hydrogen. So it displaces hydrogen from water. The metal oxides, which are soluble in water, they get dissolved to form hydroxides. For example, those for potassium and sodium, they will dissolve to form their hydroxides. And the hydrogen gas which is released, the hydrogen gas, it ignites to produce water again. Due to the amount of heat produced, whatever the hydrogen gas is there, this hydrogen gas reacts with oxygen to form water. Got it? Got it or not? Yes, any doubts here? Metal will react with water to form metal oxide and liberate hydrogen gas. This is the primary reaction. So, Dharya,
Yes, sir.
okay, will all the metals produce hydrogen gas?
Yes, sir.
No, all metals do not produce hydrogen gas. First of all, only the metals which are over here. So the metals, that is potassium, sodium, calcium, magnesium, aluminium, zinc. Only these are the metals which produce hydrogen gas on reaction with water. Even in them, potassium and sodium, when potassium and sodium react with water, you won't find hydrogen gas.
Okay, sir.
So whatever hydrogen gas is produced during the reaction, that hydrogen gas, it burns out. For example, here we observe that hydrogen gas is produced, but this hydrogen gas, it further reacts with oxygen to produce H2O. So steam will be produced, and the metal oxide like sodium oxide which is formed, it will dissolve in water to form sodium hydroxide. So understood, for these two, for potassium and sodium, the reaction occurs something like this. You will have potassium reacting with water. You will have formation of K2O plus hydrogen. Okay, but this hydrogen gas, it will burn up quickly. Hydrogen gas burns up, and this hydrogen will burn with oxygen to produce H2O. The K2O produced, or potassium oxide produced, it dissolves in water to form KOH, potassium hydroxide. So finally, the product that you will be getting here is KOH. You will not get K2O and hydrogen. But the same thing if you are doing with magnesium. So magnesium reacting with warm water will give you magnesium hydroxide plus hydrogen gas. How the hydroxide will be formed? The hydroxide will be formed when magnesium oxide is formed. That magnesium oxide will get dissolved in water to form magnesium hydroxide, and you will have hydrogen gas. Since the sufficient amount of heat is not produced, so you will have hydrogen gas formation which will escape from the reaction. Okay, the same thing if you go on with other, like if you start reaction of aluminium with water, so it won't react with warm water, it will react with steam. So aluminium will react with steam to form aluminium oxide, Al2O3. It will react with aluminium oxide, that is Al2O3. This Al2O3 plus hydrogen gas will be formed. Now this aluminium oxide will not dissolve further to form aluminium hydroxide. You won't get aluminium hydroxide here. The reason being aluminium oxide is insoluble. So the same reaction producing different products for different metals. Okay, so let's refer our NCRT and see what all things are given for this reaction. See what happens when metals react with water. This is the topic which we are doing. So for this experiment, I have seen this question coming up in a number of exams. So for this experiment, if you see, you have glass wool soaked in water. Glass wool is fine glass which is soaked, it's fine thread like glass. Okay, it's a soft glass. So that glass wool is soaked in water. You have a metal sample placed in between and it is heated up. So the glass wool is heated up. What do you think? Why are we heating the glass wool? Yes, why are we heating the glass wool?
Sir, so that
Siddharth? Hmm?
sir, the moisture in the glass wool which is soaked in water will go, sir.
The moisture in the glass wool? No. We want that water to boil up. We want that water to turn into steam. Okay. So that water, it turns into steam and it reacts with the metal sample placed in between. So when it reacts with the metal sample, then it will form the metal oxide and hydrogen gas will be liberated. So the hydrogen gas which is liberated, the hydrogen gas which is liberated, that hydrogen gas, it passes through the delivery tube. It passes through the delivery tube into this water column, or you can think of this as a solution, soap solution. So here in the water column, this hydrogen gas passes up. So you will observe here bubbles of hydrogen gas. So you will observe here bubbles of hydrogen gas coming up. So these bubbles of hydrogen gas, they get collected over here in this gas chamber. Okay, which can be further tested for hydrogen. That means you can burn that gas, and if that gas burns with a popping sound, it means that the gas produced was hydrogen gas. Got it?
Yes, sir.
So here basically the metal sample which has been kept here, it is aluminium. So see, the reaction is here, metal plus water we just discussed. Metal plus water will give you metal oxide plus hydrogen. Metal oxide plus water will give you metal hydroxide. But the second reaction, it is applicable only for alkali and alkaline earth metals. So see, the metal oxides that are soluble in water dissolve in it to further form metal hydroxide. But all metals do not react with water. Got it? So see, we just discussed that potassium and sodium, they are highly reactive. So potassium and sodium, they react violently even with cold water. So see, potassium plus water giving you potassium hydroxide plus hydrogen. So this reaction is accompanied in two steps. Got it? The hydrogen which is produced here, it catches fire immediately. So see, that the evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Hence, you will obtain hydrogen gas. Okay. Now, the calcium, it starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. The bubbles of the hydrogen gas which are formed, they stick to the surface of the metal. And decreasing its density and hence making it float. तो लगेगा ना ये लगा ठीक है ये अगर दिखता है कौन वाला है ठीक ठीक कितना लगेगा ठीक okay see so calcium it starts floating because the bubbles of hydrogen gas formed because of the bubbles of hydrogen gas which are formed these bubbles of hydrogen gas they decrease the density and they carry calcium to the surface. Got it? Magnesium does not react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen. It will also start floating due to the bubbles of hydrogen gas sticking to its surface. So both calcium and magnesium, they react with water to form calcium hydroxide and magnesium hydroxide respectively. Their oxides are soluble in water. For aluminium and iron, they also react, but they do not react even with hot water. Rather, they react with steam. Okay, so metals like aluminium, iron, and zinc do not react either with cold or hot water. They react with steam to form the metal oxide and hydrogen. So aluminium, iron, and zinc, they react with water to form their oxides and liberate hydrogen gas. The metals below that, that is lead, copper, silver, and gold, they do not react with water at all. The reason being they cannot displace hydrogen. Understood everyone about the reactivity with the metals? Reactivity of metals with water?
Yes, sir.
Okay. So just I am providing you a quick summary of this. Ayonija?
Yes, sir.
Yeah. So did you get it?
Yes, sir.
Okay. So see, your learning of this reactivity series will help. Okay. So we remembered it in this way only. Potassium, sodium react with cold water also, and here the product formed will be their hydroxide. You will be getting here KOH plus hydrogen. The hydrogen which is produced, it burns out easily. It burns quickly. Okay. For calcium and magnesium, the calcium also produces calcium hydroxide and magnesium also produces magnesium hydroxide. And hydrogen gas is produced. Also, they float on the surface of water. Aluminium and zinc, they react with steam, so they form only their oxides, Al2O3 and ZnO. It will also form Fe2O3. Iron also reacts with steam to form Fe2O3. The metals below it, that is lead, hydrogen, copper, mercury, silver, and gold, they do not react with water. Understood this?
Yes, sir.
Yeah, anyone having any doubt regarding the reaction of metals with water? No. Next one is, what happens when metals react with acids? So I think everyone can guess this. What will happen when a metal reacts with an acid? Yes, what happens when a metal reacts with an acid? What happens when a metal reacts with an acid?
Sir, salt and hydrogen is formed.
Okay, salt plus hydrogen gas will be liberated. You will have a formation of salt and hydrogen gas. Then okay, salt and hydrogen gas. So any metal with dilute acid will give salt plus hydrogen gas. The hydrogen gas. Okay. Yeah. When will the hydrogen gas will not be produced? See, when metals react with nitric acid. Okay. So nitric acid, what is there in nitric acid? See, we are looking for reaction of metal with acid. A metal react with acid to produce salt plus hydrogen. Okay. Salt plus hydrogen will be produced. But if you make any metal react with HNO3, HNO3 is our nitric acid and it is strong oxidizing. So HNO3 is strong oxidizing agent. So nitric acid or HNO3, it is a strong oxidizing agent. That means it can be oxidized. It provides a nascent oxygen for the oxidation. So for the reaction of this, again you will have the formation of salt, but the hydrogen will not be produced. Here you will have the formation of water, as whatever hydrogen is produced, it is oxidized to water immediately. Immediately on reaction with HNO3, whatever hydrogen is produced, that hydrogen reacts with nascent oxygen to produce H2O or water. Like a few metals like manganese can produce hydrogen even with dilute HNO3. So magnesium and manganese, they react with very dilute HNO3 to evolve hydrogen gas. So HNO3 has to be very dilute, then only it will be able to evolve hydrogen gas. Okay. Now here is something about aquaregia. Just go through this aquaregia. What's written about aquaregia here? Aquaregia, it is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. So concentrated HCl and concentrated HNO3 both are taken here in the ratio 3:1. See, either HCl or either HNO3, none of them can dissolve gold. They cannot dissolve gold because they are not reactive towards the gold. But a freshly prepared solution of HCl and HNO3 in the ratio 3:1 can dissolve gold even though neither of these acids can do so alone. So aquaregia, it is highly corrosive, fuming liquid It is one of the few reagents that is able to dissolve gold and platinum. So which are the least reactive metals? We have gold and platinum. They are also soluble in aqueous. Yeah. Okay. The next topic is reaction of metals with metal salts. So here, this is basically your displacement reaction. Okay, does anyone remember the definition of displacement reaction?
Sir, when a more reactive substance displaces a less reactive substance from its salt compound, then it is called displacement reaction.
See, it is something like this. When a active metal or reactive metal displaces a metal ion from its aqueous salt solution, we call the reaction as a displacement reaction. Okay, so what is a displacement reaction? A displacement reaction is a reaction of a metal with a metal solution from which the metal is able to displace a metal ion from. Some examples include, which you have studied, like you have studied for copper sulfate reacting with zinc. So what happened when copper sulfate react with zinc? Yeah, what happened?
Zinc sulfate, yes.
Yes. You will have the formation of zinc sulfate and copper. Okay. So we say that zinc has displaced copper from its solution. Okay. So what will be the color changes that will be observed here?
From blue to white.
Yeah, what color changes?
From blue to white.
Blue to colorless. The solution will change from blue to colorless as copper sulfate solution is blue in color. So here you will have the formation of zinc sulfate, ZnSO4 and copper. So this is blue in color. This will be colorless. Okay. Then what will happen when you have CuSO4 reacting with iron? Yeah, Rijwana Sheikh, what will happen when copper sulfate react with iron?
Sir, the iron displaces the copper from its sulfate.
So what product will be formed?
Iron sulfate and
Iron sulfate and copper. So what are the changes that you will observe?
Blue to green.
the blue color of the copper sulfate will fade.
Okay. And what about this copper?
It changes to brown, and if you, iron sulfate will change to green.
Yeah, so what will happen to this copper? See, we observe the deposition of copper. on the iron object, whatever has
It
been
becomes
placed.
black.
Not black, it becomes brown, cuprish brown. You have cuprish brown deposition on the iron material which is placed over there. Okay, then what are the changes observed if you have a reaction of FeSO4 with zinc? Will there be any change?
No.
No, sir.
No, no change.
Yes. No, sir. Zinc is more reactive than iron, so
So
zinc displaces iron in its sulfate solution.
yeah, zinc will displace iron to form ZnSO4 and iron. You will get ZnSO4 plus Fe. Got it? Okay. So by all of you will continue from here in next class. Thank you everyone.
So what will be the color change?
The color change will be green to colorless.
Bye, sir.
Zinc sulfate is colorless, and you will obtain the deposition of iron on the zinc.
Okay, sir.
Okay, sir. Thank you, sir.